Already looked at trigonometric identities in the past. In fact, you'll remember some of the Pythagorean identities that we covered. And you'll see over here we covered sine squared theta plus cosine squared theta equals 1. It's a regular Pythagorean identity, and we can use that if we have what we believe is the cosine value of something. So if I have cosine theta is equal to 5 over 4, well, I know for a fact that if I square that and then I take 1 and I subtract that and then I take the square root of that, I will get the sine value for that one. Not the sine angle, but at least I will get sine theta is equal to a value. We know how to do this. We've done it before. We can do the same thing if I have been given a cosecant value or a cotangent value, and I can do the same thing if I've been given a secant value and a tan value. What's even more interesting is that I can take this cotan value here and I can actually use its reciprocal to get its tan value. Same thing with cosecant. I can use that reciprocal in order to get its sine value. So I can use these in any circumstance as long as I'm using them, as a way of simplifying. And here's an example that we can use. Oh, actually, these are proofs, so we don't necessarily need to go into the proof. I'm not going to ask you to prove these as of right now, but calculus is certainly going to kind of get you into this idea of mathematical proofs. But what I'm looking at here, what I would like to show you are these even-odd identities, and then this possible idea of using these even-odd identities, using these Pythagorean identities, so that we can rewrite certain functions that we have been given, so that we can rewrite them into additional identities. So for example, I'm going to scroll down pretty quickly down here, and I'm going to show you an example. So that's something that we might go through. So for example, we might want to verify the trigonometric identity to verify that tan theta and cosine theta is equal to sine theta. And let's see how they go about doing that. So one thing that we can do is we can certainly look at the fact that tan theta can be rewritten as sine theta over cosine theta. That is an identity that is written right. It's written right here. These are quotient identities. Tan theta can be written as sine theta over cosine theta, and cotangent theta can be rewritten as its reciprocal, cosine theta over sine theta. So I can use down here that identity that says, well, tan theta can be rewritten as cosine theta over, or sine theta over cosine theta. And then when I do that, cosine theta and this value cosine theta, as you can see, they will cancel each other out. And I'm going to be left entirely with sine theta. And so that's the proof. We can try it here with cosine theta times cosecant theta times cosine theta times tan theta is equal to 1. So let me actually go over here and do that. Let me write cosecant theta times cosine theta times tan theta is equal to 1. Well, let's do a few things. Cosecant theta, is there an identity that I could use that might be able to help me out? Well, one identity that I could use is 1 over sine theta. So I could certainly try to use that. Let's go ahead and do that. 1 over sine theta. And I'm going to leave cosine theta here. And tan theta can be rewritten as sine theta cosine theta. And so all of these are being multiplied into each other. Well, let's look at this. Well, sine theta here can cancel out with this sine theta here. This cosine theta here can cancel out this cosine theta here, and I'm left with 1. I'm using these identities that you see here on the left, and I'm rewriting cosecant theta using these identities in an attempt to see if I can prove that certain identities, in fact, are going to equal, if I multiply them together, are going to equal some sort of property. The next example that we can look at down here is verifying the equivalency of using these even-odd entities. So for example, if I have 1 plus sine x, and I'm going to multiply that by 1 plus sine minus x, so I'm going to put in a value for x, like some angle, some radian or degree, but it's going to be the negative version of that degree. So there's going to be a reference angle that I could certainly use, but I'm just going to use this negative x instead, and I'm going to state that this potentially is supposed to equal cosine squared x. And I'm going to verify that using these even-odd identities. Now, what do these even-odd identities mean? These even-odd identities are up here. I can go back to them. If I have a negative, if I use a negative angle for tan, I will get a negative. That's the same as me taking that same angle. That's not negative. It's the positive. It's the reference angle. But I'm going to get a negative result. Cotangent is going to work in the same way. If I use a negative angle, that's going to give me a negative result if I were to take that same angle positive. Sine negative theta is going to be rewritten as negative sine theta. Cosine negative theta, or I'm sorry, cosecant negative theta can be written as negative cosecant theta. And cosine negative theta is written as positive cosine theta, and secant negative theta is written as positive secant theta. These are known as odd identities, okay? And this is known as even identities here. And we can use these identities in order to rewrite and verify certain problems that will help us understand, excuse me, if something is in fact equal to something else. So we're going to use those even-odd identities right here to verify that. Now, did we did we answer the question, if I take the negative value, so negative theta of sine, is that going to give me a positive sine value, or is it going to give me a negative sine value? Sine was odd, so it's actually going to give me an odd value. It's going to give me a negative value. So this 1 plus sine x, this 1 plus sine minus x, this is actually can be rewritten as 1 minus sine x, because I'm using this particular odd identity. That's sine of negative x can be written as negative sine of that same value, of that same angle, but now it's the positive angle. I can therefore then look at this and go, well, you know what? This is in fact a difference of squares. And that's something that math is now expecting you to see. They are expecting you to see these patterns that we've learned in the past, especially with Algebra 2. You're supposed to look at that and go, oh, that's a difference of squares. And so therefore I can rewrite that as 1 minus sine squared x. And then I look at that and go, oh, I recognize 1 minus sine squared of x. That's the same identity that is written up here. If I can scroll to that, that's right here. If I were to subtract sine squared theta from both sides, I get 1 minus sine squared theta, which means that this answer, therefore, is going to be cosine square x. And that's what we were proving. We were proving that this here is in fact just cosine squared x by using even odd identities and using other identities that we've learned in math. So we can verify if this is the same by using the same even odd identities. So let's go ahead and look at this solution. So what do they do? Well, they're going to take this and they're going to rewrite it using the secant squared identity. Remember what that secant squared identity is, and I'm going to go ahead and scroll up to that one as well. There was an identity that had secant in it, and that was 1 plus tan squared theta equals secant squared theta. And so if I come back down here and show us that example, I can rewrite secant squared theta minus 1 as tan squared theta plus 1 minus 1. So maybe I should show you how that works over here. So let's go ahead and let me clear this out. And let me show you this verification. So secant squared theta minus 1 is going to be divided by secant squared theta. And that is going to equal sine squared theta. This is an identity, and I want to prove that this identity is in fact correct. If I were to scroll back up to these identities that are right here, this says that 1 plus tan squared theta is equal to secant squared theta. Well, then I can rewrite this in the following way. This secant squared theta can be written as 1 plus tan squared theta, and that's going to be subtracted by 1. That's a t, by the way. Let's make that. And that's going to be divided by secant squared theta. and that's going to be equal to sine squared theta. Well, this one will subtract from that one, and I will be left with tan squared theta over secant squared theta equals sine squared theta. Going back to the example that's down here. So we can see that that's exactly what they wrote. And then how do they continue? Well, we will continue by basically saying, by rewriting it as tan squared theta times 1 over secant squared theta, and recognizing that 1 over secant squared theta is cosine squared theta. How do they know that? Well, what is 1 over cosine theta? Well, that's secant. Isn't the reciprocal of cosecant, or isn't the reciprocal of cosine? If I take cosine and I take its reciprocal, isn't this equal to secant? Isn't that true? If I were to take the reciprocal of secant, isn't that equal to cosine? Of course it's true. So if I were to take the reciprocal of 1 over secant squared theta, what would I get? I would get cosine squared theta times tan squared theta equals sine squared theta. And that's exactly what they wrote here. And then we can rewrite tan, and I'm going to go ahead and scroll down a little bit. I'm going to rewrite tan as sine squared over theta, cosine squared over theta, and recognize that these will in fact cancel out. And sine squared theta will in fact equal sine squared theta. This is true. So this particular identity is true. Now, there's the elephant in the room. The question that you guys are probably asking me, and you're probably sitting there going, I don't understand. This is what takes practice. This is what requires you to play with these identities. There really is no clean method here. As you can see, there's no clean method of, I know exactly what to do here, and I know exactly how to make this happen in this way. You have to identify and recognize these identities and hope and sort of think ahead that the identity that you're going to apply is going to make headway for you. There's no clean-cut method. You do understand what you're looking at. I guarantee that you understand this because what you're simply looking at are just identities. You're going to rewrite a particular section like secant squared or 1 over secant squared, and you're going to come up with another way of recognizing how that could be rewritten. You can recognize that 1 over secant squared theta is rewritten as cosine squared theta. The problem is that you're not going to get good at this until you keep practicing it. So you ask ChatGPT to give you some identities, to give you some even-odd identities that you can start proving. You got to get these things in your head, and you got to be able to work on them. So let's try another one, and let's just see how difficult this actually can be, or how easy it can be. I want to prove to you that you do really know what you're looking at, but you just have to need the practice of seeing these identities in your head and being able to look ahead and think ahead. So let's look at cotangent theta. That's going to be divided by cosecant theta, and that's going to be equal to cosine theta. Now, a couple of things that I'm looking at. Again, I don't know a clear-cut method to solve this. I have to think ahead. Number one, I have a cosecant theta. The reciprocal of that is sine. I have a cotangent that actually is cosine over sine. So I could try, and again, as you can see, there's no clear-cut method here for me. I'm going to rewrite cosine of theta, and I'm going to multiply that by sine theta. How do I know it's sine theta? Because one, I'm rewriting this as cosine. Let me even back up on this one. I'm going to rewrite this as 1 over cosecant theta. And I'm going to change now 1 over cosecant theta as sine theta because I recognize that identity. I'm sorry, this is cotangent. Cotangent is written as cosine theta over sine theta. And I'm going to multiply that into sine theta. These cancel out. and cosine theta does equal cosine theta. I have proven that identity. These are problems that you are forced to show work. You have to show the work. You have to prove that these identities, in fact, are equal to each other. Excuse me. So you can't just state that they're true. You have to actually physically show that this can be, this can derive from this, that this derives from that this derives from this, and that cosine theta equals cosine theta is, in fact, now your proof. That's what a proof is. Proof must absolutely guarantees work. So if you don't show work in your proof, there's no proof, which means there's no credit. There can be zero credit to basically saying, is this true? And you say true, you haven't proven it. So you have to make sure that you prove these things true. Again, how did I know to do it this way? I didn't. Again, I don't have to understand how to do all of these proofs. All I have to understand is the identities. And all of the identities, they're written right here. These identities that are right here, I can always rewrite tan negative theta as negative tan theta. I can rewrite sine theta as 1 over cosecant theta. I can use any of these identities, any of these quotient identities, any of these reciprocal identities, any of these even odd identities or these Pythagorean identities. I can use any of them, whatever it takes. And the only way to really get good at this is to practice and to start thinking ahead of how and what you do plan and how it's going to work so that I can get to the correct proof of this. And the way I solved this is that I'd realized that cosecant, the reciprocal of that, is sine. And I recognize that cotangent, the reciprocal of that, or the cotangent, is cosine over sine. And so then I'm realizing, oh shoot, or good, these things, sine theta, will cancel out. I do have cosine on my numerator there. Again, thinking things through, figuring out where I need things to fall into place, and then writing that out. And if it doesn't work, you're going to have to start from the beginning and try a new plan. All right, what else can we do? Creating and verifying an identity. Create an identity for the expression 2 times tan theta secant theta by rewriting strictly in terms of sine. So we want to rewrite this only in terms of sine. So here's the solution that they're looking at. Again, how can I rewrite tan and secant in a way where I think I'm going to get the sine value? Well, first of all, secant is going to be rewritten as the reciprocal of 1. It's 1 over cosine. And tan is sine over cosine. So I have a little bit of a problem there. I mean, it looks like cosine is on the bottom. And as you can see, that's what's going to happen here. I'm going to have 2 times sine theta divided by cosine squared theta. Well, that's a bit of a problem. What can I do there? Again, you could look at what's going on the bottom there. They rewrote cosine squared theta as 1 minus sine squared theta. Again, you're asking yourself, is there some identity that I can use on cosine squared, because that's the only one that's left here? Is there some identity that I can use on cosine squared that's going to leave me with sine? And at this point, there's no reciprocal, there's no even odd identity that you can use. You're stuck with the Pythagorean identities. And there is only one Pythagorean identity that's going to work, and that is 1 minus sine squared theta. That's the only one that's going to actually work for you in this case. So I can rewrite 2 times tan theta times secant theta in terms of sine strictly is equal to 2 times sine theta divided by 1 minus sine squared theta. And that's how you do that. Again, you just can't do this without at least showing the work that's necessary to get us forward. Here's another one. Verify that this identity, sine squared negative theta minus cosine squared negative theta divided by sine negative theta minus cosine negative theta is going to be equal to cosine theta minus sine theta. Excuse me. Let's look at this for just a second. We can recognize, and I could do some work over here before we even look at the form. Look at the solution. I can recognize that sine squared negative theta is negative sine squared theta, and cosine squared negative theta is positive cosine squared negative theta. So that's still going to be written as minus cosine squared negative theta, regular theta. And that's going to be all over negative sine theta, and that's going to be over minus cosine theta. So it looks like there's some difficulty here. But an interesting thing comes to mind. You know, sine squared theta plus cosine squared theta equals 1. And if I multiplied everything by negative 1, well, I get negative sine squared theta minus cosine squared theta equals negative 1. So, you know, it's very possible for me to rewrite this as negative 1. And of course, with sine theta minus cosine theta, both of these being negative, I can rewrite this whole thing, and I'll rewrite it over here, or down here, as 1 over sine theta plus cosine theta. Now, am I done? I'm verifying the identity that this is cosine theta minus sine theta. Well, I'm not very close here. And there are certain things that I probably haven't real. For example, this could be written as 1 over sine theta. So I'm finding myself kind of stuck. So it's very possible that I misused a property. It's very possible that I may have got myself stuck in a place where I don't recognize a property. It's good that we've got these examples, because these examples help us recognize, okay, I have a gap. What is actually the gap that I missed? What did I miss here? I could have missed something, so let's see what I missed. Well, they rewrote it exactly the same way that I did. Negative sine theta. But here's my gap. They are rewriting this whole thing. This is something that I did not realize, that when I take the identity of sine squared negative theta, I rewrite it as minus sine theta squared. Well, that is going to give me a positive value. So that's going to be sine theta squared. If I take the same thing here, cosine squared negative theta is going to be written as cosine theta squared. And of course, I am subtracting that. Cosine is even. So that can be written as sine theta squared minus cosine theta squared. So it's not this. It's positive. And the same thing down here is written. So nothing changes down there. And it's noticed here, sine theta squared minus cosine theta squared, that this is in fact a difference of squares. So now we are working a little bit backwards from that first example where we saw that there was a difference of squares and I can rewrite it in its short form. I recognize that there's a difference of squares here and I can rewrite it in its long form. Sine theta minus cosine theta times sine theta plus cosine theta. And I recognize here that these values, sine theta plus cosine theta, these values here will, I'll blow this up so you guys can see it. Did I mess this one up? I might have to re-scroll down to it. Yep. They took this difference of squares and they expanded it. They didn't, I gotta get rid of that. How do I get rid of that? It's not letting me get rid of the, that's very hard for you to read. I know it is. And I haven't, there it goes. They expanded this into this. You can see here's my mouse. This is the expansion. They can take these two values right here and they can cancel them out. And it's going to leave this with a negative sine theta minus cosine theta. And therefore that negative gets multiplied into this value. And so now it's negative sine theta plus cosine theta. And so there is the proof. Again, these are gaps that we can have problems with. These are gaps where we're like, oh shoot, I'm not thinking along those lines. I think it's time for me to start thinking along those lines. I need to realize that I could possibly be working backwards from a difference of squares. I could be working with difference of squares in a way, in this fashion, where I might need to remember these rules for difference of squares, not only in one direction, but in another direction. Yes, and again, you might be thinking to yourself, I don't understand what's going on. Again, this is not a matter of I got to understand exactly how to do this. You're not going to get you're not going to get a full understanding of all of this unless you can get a practiced mind of what we're looking at. Again, you'll notice that I had a gap. I wasn't thinking along the lines that this value right here could be expanded. I wasn't thinking along those lines. Now it's time for me to think along those lines and start realizing that if I see a difference of squares, I'm going to start looking into whether or not I should expand it or whether or not I should condense it, depending on what I'm looking at. These are more things that I can start writing in my toolbox that says, if I need to write certain proofs, what do I need to know? Well, it looks like I need to start knowing difference of squares forwards and backwards. That's going to be my gap. So let's try that with the following identity and see if maybe I have bettered my knowledge of this by trying this one out. And I would highly recommend that you guys try to do this yourselves as well before I even get there. Because if you can get this right, then I would say that you are doing a fantastic job of practicing this. So this looks pretty darn complicated, and we're going to assume that this right here is going to eventually equal to sine theta plus 1 divided by tan theta. Well, right off the bat, I recognize this identity right here. I recognize it. It's the same thing. It's a Pythagorean identity. And so therefore, I can rewrite this as cosine theta. Again, it's a matter of seeing these identities, recognizing them, and utilizing them. You understand how to do these things. You just lack the experience of seeing these identities. And so do I. I need to remind myself of certain things. And the more I do them, you'll notice the better that I'm getting at recognizing them. So now I'm going to rewrite this as tan theta, sine theta, minus tan theta. I now need to figure out where I need to go next from here. And I'm noticing a couple of things. I'm noticing that, one thing I could do is I could take tan out of this. I'm not quite too sure if that's going to get me anywhere, but I could factor out tan. And that's what I'm going to do. And so that's what I have. I have sine theta minus 1, cosine squared theta, and then tan theta. Is that going to help me? Don't know. Excuse me. So let's see where I can go from here, given that I've just done this. Well, I can rewrite tan theta as sine over cosine, and it's possible that I could rewrite this as cotangent. I could take this out here and rewrite this as time cotangent. And cotangent can be rewritten as cosine over sine. Is that going to get me anywhere, though? I don't think so. So that's not going to get me anywhere. Well, let me think about this. I need tan theta on the bottom, so that's working. Cosine, I'm not liking this. Cosine squared theta, sine squared theta minus 1. Let me rewrite this. Sine squared theta plus cosine squared theta is equal to 1. Cosine squared theta is equal to 1 minus sine. Oh, I made a mistake. It's supposed to be 1 minus sine squared theta, so that is not the answer that's supposed to be. Let me get an eraser. Let me erase this. It's not cosine theta. Let me just rewrite it. sine squared theta minus 1. Well, interestingly enough, and as I said before, you can always think about difference of squares in these, and interestingly enough, that is a difference of squares. Sine squared theta minus 1 is in fact a difference of squares. That can be written as sine theta minus 1 sine theta plus 1. And again, I take tan out, factor it out. I'm left with sine theta minus 1. There we go. These cancel out, and I'm left with sine theta plus 1 divided by tan. Whew. Okay, so again, my biggest problem was that I went a little too fast with an identity, got myself in trouble, went back, proved that that identity that I did was false, and then came back to this problem here. And literally, I just started throwing a couple of things against the wall just to see if they would work, if they would stick. And difference of squares, I think, is going to start showing up in my mind now from here on out to see whether or not that I can actually, apply that in some fashion. Because if I can, why not? Let's give it a shot. Let's see if I can actually apply that, see if it works. It did in this case. It really did solve the problem for me. Cool. So let's keep that in mind. Difference of squares can probably help us in certain things. All right, so let's see if that's basically it. Rewrite a trigonometric expression using difference of squares. If we have 4 times cosine squared theta minus 1, well, we can, in fact, rewrite this as a difference of squares. That can be written as cosine theta plus 1 cosine theta minus 1, and that can be multiplied as 4 on the outset. Or I can just use, I could go ahead and also use 4, and as you can see, 2 times 2 cosine theta is going to give me 4 cosine theta. I can make that part of my difference of squares. I suppose that I can do that. That'll work just fine. We can try it here. Of course, we see that 25 minus sine squared theta. How can I rewrite that as a difference of squares? Well, 25 is, I take the square root of that, that's 5. And the square root of 9 sine squared theta is 3 sine theta. So I rewrite that as 5 plus 3 sine theta times 5 minus 3 sine theta. So again, difference of squares is a very popular thing that comes up from time to time, and that's the end of that. So for homework assignment, I'll have that on my BC. If you have any questions for the teacher, the substitute teacher that is there, if you want to go over a few of these problems and maybe work them out with the teacher that is there, by all means, please go ahead. If you want to rewatch this at home, by all means, please go ahead. Hopefully, this has been a helpful video for you, and hopefully you can tackle that homework again. It takes practice. I do think you guys know what to do because all you are doing is just applying an identity. And yes, how do you know which identity to apply? You just got to work it out. It's going to start slow, and you're going to pick up some speed as you guys go along. Practice. Trust me, you will get good at this.